Okay, so 9, 3 starts with 39. 39 is, now we're moving into three equations and three unknowns. X minus 4y plus 3z is equal to 3. And then we've got negative y plus z is equal to -1, and z is equal to -5. So you want to use back substitution. They've already given us 1 point, which is z is -5. So if negative y plus a -5 is equal to -1, so I get y is equal to -4. And then I do the other one, x minus 4 times -4 plus 3 times -5 is equal to 3. That's x plus 16 minus 15 is equal to 3. So x is equal to 2. Back substitution. Alright, moving on, doing 40, same thing, back substitution. My equations are 4x minus 3y minus 2z equals -65. 8y minus 7z is equal to -14. Z is equal to 10. So again, they've already given me one of my solutions at 10. So I do 8y minus 7 times 10 is equal to -14. 8y is equal to 56. And so y is equal to 7. Alright, and then I can do the same thing with 4x minus 3 times 7 minus 2 times 10 equals -65. Okay, so 4x minus 21 minus 20 is equal to -65. 4x minus 41 is equal to -65. 4x is equal to -24, so x is equal to -6. And there's my solutions for 41. Okay, 43. I want you to do that using your calculator to put the equation in row echelon form. And then once you have it in row echelon form, you can use back substitution to solve. So we start with x plus 2y plus 6z is equal to 4. -3x plus 2y minus z is equal to -4. 4x plus 2z is equal to 16. Alright, so to go in the calculator. So first off, what does my matrix look like? It's a 3 by 4 with 1, -3, 4, 2, 2, 0, 6, -1, 2, and 4, 4, 16. Okay, we're going to rewrite that in row echelon form. Second, matrix. I'm going to edit matrix A. Edit A. It is a 3, 4, and I get 1, 2, 6, 4, -3, 2, -1, 4, 4, 0, 2, 16. Alright, so getting that, I do second mode to quit, second matrix, go over to math, scroll up or down, you want to get to REF, enter, go back to second matrix, select it, close the parentheses, hit enter. And I prefer to write these as fractions, so I'll hit math, frac, and there are my fractions. So I take that and I get these equations. I get x plus 1/2 z is equal to 4. Get y plus 11/4 z is equal to 0. And I get z is equal to negative 16/5. Okay, so if I've done everything right, that's z. And then back substitution for both of these, x plus 1/2 times negative 16/5 is equal to 4. Y plus 11/4 times negative 16/5 is equal to 0. So the y gives me negative 44/5, so 44/5. X gives me minus 8/5 and equals 4, so x is equal to 28/5. So my solutions for this particular problem are 28/5, 44/5, negative 16/5. Just making sure, I'm going to double check to make sure my matrix is what I wanted. 1, 2, 6, 4, negative 3, 2, negative 1, 4, 4, 0, 2, 6, 18. And so there we go. There's our solutions. By no means pretty. Okay, doing the next one, 45. Okay, 45 is x minus 2y plus z is equal to negative 6. And then I've got 2x plus minus 3y equals negative 7. Get negative x plus 3y minus 3z is equal to 11. So the matrix I want is 1, negative 2, 1, negative 6, 2, negative 3, 0, negative 7, negative 1, 3, negative 3, 11. So I'll go back into my matrix, go second x inverse, get the matrix, go over to edit, to 3 by 4. In this case I want 1, negative 2, 1, negative 6, 2, negative 3, 0, negative 7, and negative 1, 3, negative 3, 11. Okay, second mode to quit. I want to ref A. So I get that. Oh, a dependent system. So I get these equations. I get x minus 1.5y is equal to negative 3.5. I get y minus 2z is equal to 5. Okay, so generally with these, we'll let z equal a. Okay, and so that means y minus 2a is equal to 5. So y is equal to 5 plus 2a. And then in the top one, x minus 1.5 times 5 plus 2a is equal to negative 3.5. X, so we get x minus 7.5 minus 3a is equal to negative 3.5. And so if I finish that off, I get x is equal to positive 4 plus 3a. So my solutions for this particular problem are what? X, Y, Z. You can write that as an ordered triple if you want. Okay, let's do 47, and then we'll stop that for this little clip. 47 x plus, they leave a big gap, plus 4w is equal to 1. And the gap's there to indicate 0 is 3y, plus z minus w is equal to 4. 2y minus 3w is equal to 2. 4x minus y plus 2z is equal to 5. Again, I'm going to do this on the calculator. Put in row echelon form, you get 1, 0, 0, 4, 1, 3, 1, negative, start with y. 0, 3, 1, negative 1, 4, 0, 2, 0, negative 3, 2, and then 4, negative 1, 2, 0, 5. That makes this one a 4 by 5 matrix. So go into my second matrix. I go over to Edit. Matrix A is now a 4 by 5, and it has 1, 0, 0, 4, 1, 0, 3, 1, negative 1, 4, 0, 2, 0, negative 3, 2, and 4, negative 1, 2, 0, 5. Alright, so exit, second mode to exit, hit second enter to bring back the last thing you did, and hit enter. Oh, I can't see everything in one, so I generally will change that to a fraction. And what does that tell me? It tells me a few things. It tells me x minus 1/4 y plus 1/2 z plus 0 w is equal to 5/4. It also tells me y plus 1/3 z minus 1/3 w is equal to 4/3. Tells me z plus 7/2 is equal, w is equal to 1. It tells me w is equal to 0. Okay, well that makes my life a little bit easier. If w is 0, then I can come over here and say z plus 0 is equal to 1, so z is equal to 1. Then I can say y plus 1/3 times 1 minus 0 is equal to 4/3. So y is equal to 1. And then if I have y and z, I can do x minus 1/4 times 1 plus 1/2 times 1 is equal to 5/4. Okay, and that tells me x is equal to 1. So my solution is points 1, 1, 1, 0. Alright, we'll stop there on this video and we'll pick it up on the next one.